Mr. Lewis. He's just going to sit there and nod because he's all tired and everything today.
Yeah.
This is video 65, and we're going to do some problems with Venn diagrams can help. They involve intersections, unions, and complements, all that good stuff. And when possible, use a diagram.
Right. All right. So here's our fun problem. So we have a real estate ad that suggests that 64% of homes or for sale have garages, 21% have swimming pools, and 17% have both.
Good. I got my calculator, man. Right here. We're ready.
So we want to know the probability that a home has either a pool or a garage.
Let's just do the Venn diagram.
Yes.
All this will fall apart. This will all be easy with the diagram.
Right. So we have two categories. So we're going to make two circle.
So the first one's garage and the pool. And why don't you put a big rectangle around it? Because that kind of represents the universal set.
Oh.
Yeah, we may have some that don't fall into the circles.
That's true. I'll come into my problem.
Okay, so we start filling in stuff. So Mr. Lewis, the very first thing people do, because it's the first number, is they try to put the 64% somewhere.
Right. They try and put that here, but we don't want to do that yet.
No, why?
Because that 64% also includes the people that have both a garage and a pool.
Yeah, so we don't know how to split it yet.
Right, we don't want to double count.
And the same thing with the 21% who have pools. We don't know how that 21% splits up in the circle. But we can start with the third number.
Right. This 17% goes right
As
there
both.
in the middle.
Now we can go back and use the 64%.
Mm-hmm.
Of the 64% that have a garage, 17% is already there in the middle. And if we subtract, oh man, I went to all that trouble to find the calculator.
And it was only 47.
47, there you go. So there you go. So total, 47 and 17 total 64%.
Mm-hmm.
But now we know the breakdown. So we had to start with what goes in the intersection.
Right.
Same thing here, 21% have swimming pools, but we know that 17% are in the both categories, so at least 4 pool category.
Right.
So how many people have neither, or what percent have neither garages or pools?
Well, here's 21 and 47 is 68, so it looks like 32% have neither.
Yeah, so 32. Now,
that goes out in the...
We know the breakdown of all these places. So now we can kind of answer any question we want about complements, unions, and intersections.
Right.
Okay. So what percent have a pool or a garage?
Okay, well, pool or a garage, that would be everything in these three circles.
68%.
Right.
Can you write that up there? Oh, never mind, too late.
Nope, I'm going to write right here.
Okay, beneath that, so right underneath it,
yeah.
Let's just practice using the general rule. So the probability, or we can do it maybe down here. Let's go down. So the probability of garage union pool equals the probability of getting someone who has a garage plus the probability of someone getting a pool minus the probability someone has both. So let's just see if this works out. So the Venn diagram is so easy, but we want to make sure we know the rule here. All right. So if we take the probability someone has a garage, that was 64, plus the probability someone has a pool,
21.
That's 85, and subtract the people who have both, we're left with 68%, which is what we got from the Venn diagram.
Yes.
Okay, so the rule works. So we actually, if this is the only thing that they asked, the rule may have been quicker.
Right.
But okay, so just want to point out that we could use the general addition rule. How about neither a pool nor a garage?
Well, that would be the remaining 32% that was out here in the rest of our space.
Okay, and a pool but no garage.
Pool but no garage, 4%.
Got it. I'm going to do it this time. You ready?
Yes.
Ooh, man, that is cool. All right, suppose probably that a U.S. resident has traveled to Canada is 0.18, to Mexico is 0.09, and to both countries is 0.04. What's the probability that an American chosen at random has? I don't know, but let's do a Venn diagram, since it involves two events. So we have those that went to Canada and those that traveled to Mexico, and Let me draw the rectangle again. For those who
Don't go anywhere.
I have a spot for them. All right, this is the same thing. We can't go putting in the 0.18 into the Canada circles. We don't know how it splits up.
Nope.
And we can't go putting in the 0.09 either. We got to start with the 0.04.
0.04.
And now we go back and we can fill in the Canada. Since the total for Canada is 0.18, if you subtract 0.04, that leaves 14%, 0.14. Okay, and then same thing over here. The total for Mexico was 0.09. So if you subtract the part that's in the middle,
0.04. Too many lines, sorry.
got
We get 0.05.
it. Let's just why don't we circle the final results there?
Yeah.
So we got that plus that is 18%, plus that is 23%. So 23% are inside, 77% are outside.
Right.
Okay. All right. Now, all these questions are easy. Travel to Canada, but not Mexico.
Okay, what is it?
0.14.
Okay. Thought you were, because you said you were doing it this time, so that's why.
Travel to either Canada or Mexico? No, I was just pressing the button to make the slide come up.
Oh, I see.
Like that.
Okay, either to Canada or Mexico. Well, that's our whole sample space, so 0.23.
You know what I'm going to want to do in a minute, but let's answer the final question.
Not travel to either country, 0.77.
What is it you think I want us to do?
Probably do the rule again.
Okay, let's do the rule.
So, P of Canada, Mexico, minus, equals,
Yeah.
P of Canada, getting ahead of myself, plus P of Mexico, minus P of Canada, intersect Mexico.
Got it. All right, so it should
Okay.
equal 0.18 plus 0.09 minus the intersection was 0.04. So I think you get 0.23. Now, the reason why I bring that up is because I know the Venn diagram's handy, but the learning goals actually the laws of probability.
Mm-hmm.
That's our main focus, to be really familiar with those. It can get very abstract, and the laws could be all you got.
Yes.
All right. Well, you know it's time for. Oh, wait, let me do it.
Oh,
Journal assignment.
it is time for the journal assignment. So we're going into college years. All right. So
Oh,
the
cool.
check of dorm rooms on a large college campus revealed that 38% of them had refrigerators, 52% had TVs, and 21% had both a TV and a fridge.
You live in a dorm, Mr. Lewis?
I did, and I had all that stuff.
Oh, I never lived at a dorm.
Well, we're not all.
I was a townie. I just owned the town. Okay.
So we want to know what the probability the dorm has a TV but no refrigerator, a TV or a refrigerator but not both, and neither a TV or a refrigerator.
Wow. Great Venn diagram.
Yes.
Okay.
All
That's
right.
all.